Hello, this is the homework video for page 40, problem number 7. And this question is asking you to figure out which of these tables for number 7 are linear. And it wants you to explain your answer. And then if a table is linear, they want you to write an equation for that relationship. Remember, if you haven't already done this assignment, turn off the video and turn it back on after you've given it an honest try. And remember, if you're confused about how to figure out if it's linear, put the carets on both sides and see if you can find a constant rate of change. Okay. Question A. So when I put the carets on this side, I get 30 all the way down, and over here I get 10 all the way down. That means this is most definitely linear, and I wrote the wrong thing here. That's okay, we'll fix it. To find the constant rate of change, I can't just leave the carets like that. I have to divide these numbers by this. 30 divided by 10 is 3, so that means my equation is y equals 3x plus what the y-intercept is. And luckily on this table, they show me what the y-intercept is right in the table. It's where x is equal to 1, because that's where it crosses the y-axis. So my equation is y equals 3x plus 1. On B, when I put the carets in, I get 8, 4, 26, and 2, and 4, 2, 13, and 1. Now, it looks kind of like this is not a linear table because these are not all the same and neither are these. But if you do the division and you do 8 divided by 4, you get 2. Over here, if you do 4 divided by 2, you get 2. Over here, 26 divided by 13 is also 2. And here 2 divided by 1 is 2. This is a more complex table than you've seen before. It's the kind of table that I was talking about when I asked you in the linear reflection that you did last week whether or not you thought you could write an equation for a complex table. This is a fairly complex table because of how they count differently here and here. But then not only that, but they don't show you the y-intercept. Now that I know the constant rate of change, though, is 2, because I did the change in y divided by the change in x, I can work backwards. So here if I subtract 1, I get 0, and here if I subtract 2, which is the constant rate of change, I get 7. So that tells me the y-intercept is 7. The equation for this table is y equals 2x plus 7. Okay, on C, I got 3, 5, 7, and 9, and all of these are 1. I could show you all the division problems written out like this, but you already know that 3 divided by 1 is 3, and 5 divided by 1 is 5, and 7 divided by 1 is 7, and 9 divided by 1 is 9. So this is not linear because when you do those divisions, you don't get the same constant answer. So this is no, it's not linear. Over here, I get 13, 3, 31, 4, and here 4, 2, 13, and 1. When I do 13 divided by 4, I get 3 1/4. When I do 3 divided by 2, I get 1 1/2. Because these aren't the same answers, I know that this is not a linear table because they would give me the same answer. There'd be a constant rate of change if it was linear. So this is not a linear table. And you are now done with your homework. Have a great night, you guys.